calculator. And here's how you use the calculator, guys. So first of all, you just have to stat edit and put the data. Let's say you have data in L1. And now how do you find the standard deviation? It's very simple. Just go to stat, calc, one variable statistics, and don't put any frequency list. This is only for chapter 4 here. So just calculate. And here's the standard deviation. If it is a sample, it was about the batting averages of Sammy Sosa. So S will be right there. You didn't need to find the mean. I didn't ask you for the mean. Consistency is just finding the standard deviation, and it's S.24. This is how you find the standard deviation. No need to waste time on the formula, because if there is so much data, guys, the formula can take forever to process. Not only the calculator will give you the standard deviation, will give you the mean, which is X bar, will give you the minimum, will give you Q1, will give you the median, will give you Q3, will give you the maximum, and all those 5-number summary. The other thing that I noticed as well, guys, on the assignment, when you find outliers, many of you made a mistake there, and it looked like some students work together and they end up making the same mistake. When you do the IQR, which is Q3 minus Q1, the IQR, and then multiply by 1.5. Then later, guys, you don't take the median and subtract this. You take a Q1 and subtract. Let's say this value, guys, is 20. So you take a Q1 and subtract the 20. And then you take a Q3 and add the 20. And let's say Q1 minus 20 turned out to be 7. And let's say Q3 plus 20 turned out to be 90. So you will have outliers if they are outside of this range, 7 to 90. Anything that's inside the range is not an outlier. But I noticed many students put the median here, which is a Q2 minus 20 and Q2 plus 20. No, it's not the median. It's a Q1 minus 20 and Q3 plus whatever value you come up with here. So this is another thing I want you not just to be aware of. And the third thing is, the higher the Z-score, the better when it comes to scores on the test. And some students said, no, the lower the Z-score, the better. And just pay attention when you do your calculation. So if you put a Z-score like this, and the answer turns out to be, guys, let's say 1.245. I know some students rounded this to 1.3. That's not a 1.3, guys. You always have to round Z-score to 2 decimal places. So if you round this to 2 decimal places, it will be a 1.25. Make sure always to round Z-scores to 2 decimal places. So these are the comments about the chapter 2 assignments. The other comment, guys, when you get the class widths to be like a 4.2, you don't use a class width of 4, guys. You have to up it to the next whole number. So your class width must be a 5, not a 4. Many students put a 4 in the assignments. You already have the grade and you already have the chapter 2 assignment solution. So please compare your assignments with my solution just to get more feedback on your work on this assignment. Let's go back to the review now. Determine whether the statement is true or false. Some quantitative data sets do not have medians. No, you can find the median, guys, for any quantitative data set. So your answer here should be the statement is false. All quantitative data have medians, and then just move on. All right. Determine whether an approximation, the approximate shape of the distribution shows is symmetric, uniform, skewed left, skewed right, or none of these. What do you guys think?
I think it's D.
D.
It's symmetric? Yeah, it looks like symmetric here. It's not uniform, yeah. So see, this question will take a second, just to answer. Find the mean, median, and mode of the data set. Let me show you guys how you could do this in StatCrunch. You could put those values into your calculator and do it, but let me show you how you could have done that in StatCrunch. Open in StatCrunch, watch. And tell me, guys, if you're not seeing the StatCrunch screen. Are you seeing the StatCrunch loading?
Yes.
Okay, great. And look, guys, what you do. Stat, summary statistics, columns. Select the column and hit compute. This is the mean. This is the standard deviation. This is the median Q2. This is the range, which is maximum minus minimum. This is the minimum. This is the maximum Q1, Q3. It doesn't give you the mode. The mode, you guys, you have to figure it out on your own. So this is how you can use the StatCrunch to do this. The mode, is there a mode here?
Did you do that?
10.1. 10.1 is the mode. Any questions?
Could you do that again so I could see how you did it?
Yeah. There you go. Open in StatCrunch. So look, the hint is here, guys. Anytime you see this icon means you can use a StatCrunch. Click, and that's going to save you a lot of time from entering data into your calculator. So you go stat, summary statistics, columns. So you have to select the column and then hit compute. And it will give you everything. You just pick what you want. You want the mean, you want the median, you want the Q1, Q3, all of them are there. Okay, next question. The letters ABC are marked on the histogram. Describe the shape of the data and then determine which is the mean, which is the median, and the mode. We did this question before, guys. First of all, do you guys agree with me that the data is skewed what? Right.
Left? Oh, right.
Yeah, when the tail is toward the right, it's skewed right. And I told you guys last time that the mean will always be closer to the tail. Remember that. But first of all, we can figure out the mode. Which one is the mode, guys? Is it A, B, or C?
A.
A, because it's the highest column. The highest column is the number that occurs most frequently. And since I told you that the mean will always follow the tail of the distribution closest to the tail, so the mean must be C. And then B will be the median. We just select the answers and you should be all set. Use the accompanying data to complete the following actions. Find the quartiles, find the interquartile range, identify any outliers. I'm going to use StatCrunch, guys. If you were on campus, I wouldn't emphasize too much on StatCrunch because I know you're going to be taking the test in class and you won't have access to the computer. But since I'm allowing you to have access to the computer, I'm fine with that. All right, so compute. Okay, in order to find the outliers, what do we guys need? We need a Q1, we need a Q3. So Q1 is 58 and Q3 is, let me just do that. So Q1 is 58 and Q3. Unfortunately, I don't know why the stylus is not working as it should. There's a delay, 63. So you find the IQR, guys, which is what? The IQR will be 63 minus 58, which is 5. Then you multiply by 1.5. So that's a good chance to times 5. That will give you 7.5, guys. Then you take a Q1, which is 58, and subtract 7.5. What do you get? 50.5. Circle this number. Then you take Q3 and add 7.5. I have a 70.5. And circle this number. Any number that is between 50.5 and 70.5 is not an outlier. So let's go back to the data set and check. I'm gonna clear this. Okay, 50.5 and 70.5. So there's one outlier, guys. Can you tell me which one?
78.
78, because it's above 70.5, and that's the only outlier. Okay, so that's how you do this question. The data show the number of hours of television watched per day for sample 28. Use technology to answer part A. So find that, look, static range, guys, watch. He wants the Q1, Q2, and Q3. Look how easy it is. Columns.
That crunch is going to be available for the test.
Oh,
too.
definitely, definitely. I'm not showing it just for nothing, so it will be there.
All right.
Yeah. So Q1, guys, is 3. Median is 4.5. And Q3 is 7.5. Now you want to do a histogram, a box plot. Let me show you. You just go to graph and just do a box plot. Variable 1. And you just compare and see which one matches with that one. That gave me a vertical one. Let me show you if you can do a horizontal one just to match with what he's doing. Let me just check. Yeah, draw boxes horizontally. Oh, I didn't select the variable one. You have to select the variable that you're using. And here you go. You can match it with the figure with the correct answer. All right. The age of the winners of a cycling tournament are approximately bell-shaped. The mean age is 28.1, and the standard deviation is 3.6. The winner in one recent year was 30-year-old. Change this to a Z-score. So let me show you about the Z-scores, guys. Okay. So he says the mean is 28.1. The standard deviation is 3.6. And the value, he says it's 30. So how do you do the Z-score, guys? Watch. Z equals the value first minus the mean divided by 3.6. And what you can use the calculator right here. Clear. So I do 30 minus 28.1, which is 1.9, and then divide by 3.6. And what is the answer to 2 decimal places, guys? So what would be Z?
0.53.
0.53, I agree. Exactly. Just be careful with that. The system will mark it wrong if you put 0.52, so it will be 0.53.
For the test, we have only one attempt, right?
Yep. All right. Is the value usual? Okay, let me see here. Interpret the results. Let me show you how to interpret the results here. Okay, an age of 30 is about how many standard deviation above the mean? 0.53. Just put 0.53. Above or below, guys? The answer is positive. So would it be above or below the mean?
Above.
Above the mean. That's it. Determine whether the age is unusual or not. Remember, I told you the value of Z will be unusual if it is above 2 or below -2. Since this value is between -2 and 2, it is usual. So the value is not unusual. Unusual, not unusual means usual. So that's the answer. All right.
I apologize if this was already answered. Is there going to be 60 questions on the test?
No.
Okay.
It's just a review. So now you won't have 60 questions. Explain the relationship between variance and standard deviation. What's the relationship, guys, between variance and standard deviation? The variance is the square of the standard deviation. And the standard deviation is the square root of the variance. No negative here. Okay, the standard deviation is a positive square root of the variance. The standard deviation, the variance can never be negative, yes. So that's D. The standard deviation can never be negative, guys, and the variance can never be negative. Find the range of this data set. Let me just graph it. Okay. The range, guys, it's the largest value minus the smallest value. What's the largest value that you can
27.
see here? 34. Do you guys agree 34 is the largest? And what's the smallest?
24.
Yeah, subtract the 2 and you're done. It's 10. Okay. Find the range, the population mean, the population variance, and the population standard deviation. I'm going to do the calculator this time, guys, just to show you that we always can use the calculator as well. I'm going to clear the list, clear, enter, and then let me put the data in there. 2, 9, 15, 3, 15, 8, 12, 7, 2, and 9. I'm done. Go to stat, calc, one variable statistic. Make sure there is no frequency there. Only in chapter 4 we put that, and then hit calculate. Okay, the mean is, let me write them down. Or if you want, I can just do it here. Range. Range, guys, is the difference between the smallest and the largest. I think I have 15 and a 2, so that will be 13. Mean. Who can tell me what the mean is? It's the first value on the screen, 8.2. Population standard deviation, which is sigma, not S. He says this is a population, guys. So he says population standard deviation. So it will be 4 point, how many decimals? 1 decimal. Population variance is just square 4.6. So you want me to do 4.6 times 4.6. Uh, 4.6 times 4.6. And the reason why I'm doing a population, I took sigma because he said this is a population. So I'm just using this 21.16. And to 1 decimal, guys, it will be 21.2. Next. Range, mean, variance, standard deviation, same question, guys. I think you know what to do. So just you do the same thing as we did before. But this is a sample, guys. So what's the difference between the two now when I do the results? Stat, calc. What would be the difference, guys, when you write the answers? Let's say you put the data into your calculator and you got those results. The first value will be the mean. You just, the range is Q maximum minus minimum. The mean will be the first value. Now the standard deviation, since he says it's a sample, guys, you don't take sigma, you take what? S. That's the difference. So if he says a sample, I meant to put those 2 different questions there to show you the difference between a sample and population. Most of the time, guys, most of the time it's going to be S. But if he says population, then it is population. It's sigma. Okay, which data set has the greatest standard deviation? The larger the standard deviation, guys, the more the widely spread the data. So which one has the largest standard deviation where the data is too widely spread? More spread out. Which one do you think, guys? 1, 2, or 3?
3.
3, yes. It looks like the data is very spread out. So 3 has the largest. Which one has the second largest?
2.
2, that is correct. You see? But look at 1. It's the data seems to be confined together. That's going to have the smallest standard deviation. This is how you can tell, guys. When you see the plus magnifier, you just can click on it, to magnify the graph. Okay. Which data set has the least standard deviation? It will be 1. How are the data sets are the same? How do they differ? It looks to me, guys, that they all have the same mean. Look, 7 here, 7 is in the center, and 7. So they have the same mean, but different standard deviations. Same mean, different standard deviations. Next.
Professor, I have a question.
Yes.
If they give you a graph and they ask you to find the range, are you supposed to take the values from the x-axis or the
Yes, yes, yes. So for
Okay.
example, yeah, do you take the largest value and the smallest value on the x-axis, the last one and the first one?
y? Okay.
Yep, good question. Use the empirical rule. The mean speed of a sample of vehicles along a stretch of a highway is 66 per hour. Standard deviation is 5. What percent of the vehicle whose speeds are between 61 and 71? Let me remind you of the empirical rule. It's the 68, 95, 99.7% rule. The 68, guys, is 1 standard deviation within the mean. The 95 is 2 standard deviation. And the 99.7 is 3 standard deviations from the mean. Okay, here's what I like you to look at, guys. 61 and 71. The mean is 66 and the standard deviation is 5. If you add 5 to 66, what do you guys get? You get 71, right? And if you subtract 5 from 66, what do you guys get? 61. So how many standard deviation did you add and subtract? 1. If it is 1 standard deviation, the percent will be 68%. So your answer with this will be 68%. Now, if let's say I give you the same question on the test and I made it, I'm gonna change that. Make it 56 and 76. 56, guys, means I subtracted 10, 2 standard deviation, and then from 66 to 76, I added 2 5s, 2 standard deviation. Your answer would be 95%. So that's how, this is how you do that. I have one student who said it's not clear. What do you guys mean by that? You're not seeing the, are you guys seeing the screen okay, or you have issues with the screen? Any comments?
Fine.
Oh, is it blurry? Is the screen blurry, guys?
I can read it just fine.
It's fine.
Okay. I will make the recording available anyway, guys. So now the table shows population statistics for the age of best actor and best supporting actor winners in award ceremony. The distribution of the ages are bell-shaped. Compare z-scores. Okay. In a particular year, the best actor was 42 years old and the best supporting actor was 63. He wants you to change to z-scores. That's important, guys. You're gonna have questions on the z-scores. Okay, how do you change the best actor to a z-score? We know it was 42, so here's how you do it. Put 42 first, the x value, minus the mean, which is 45, and then divide, guys, by 7.8. Okay, what would that be? Let me just do it here. And let me do the second one before I do the calculator. For the best supporting actor, it will be, his age was 63 minus 49 divided by 14. Okay, guys, let's see what the answers are. Clear? 42 minus 45 is -3 divided by 7.8. So I got -0.38. Let's see what this z-score. 63 minus 49 is 14, and 14 over 14 is 1. So you go here, guys. The best actor will be -0.38. The z-score for the supporting actor is 1.000 with 2 decimals. Interpret the z-scores. Let's see. The best actor was less than 1 standard deviation below the mean. Why below, guys? Because it's negative. And why less than standard deviation? Because I got 0.38, which is less than 1. And the best supporting actor was, it should be 1 standard deviation above the mean. Okay, both of the ages are usual or unusual, guys. What do you think? The z-score here was a 1 and the z-score was negative. They're usual because they're not beyond 2 and -2. So both of them are usual. And then you go to the next one. How is a sample related to a population? Can you tell me, guys, which one is the correct answer?
It's C.
Yep. Let's move on. What's the difference between parameter and statistic? A parameter is a numerical description of a population. A statistic is a numerical description of a sample characteristic. What are the 2 main branches of statistics? The 2 main branches of statistics are descriptive statistics, guys, and inferential statistics. There you go. All right. Yeah, I know some of you are having issues with the screen, but I'm not sure what to do here. It looks okay to me, but hopefully the video quality will be good. Determine whether the data set is a population or a sample. The grades of 5 students in a classroom of 30, guys. Is this a sample or a population?
Sample.
Sample.
Sample, definitely. It's 5 students out of 30, so it is a sample. Determine whether the data set is a population or sample. The number of garages for each house on a street.
Population.
Population, because every single house on the street. Determine whether set or explain your reasonings. The age of each member of the House of Representatives.
Population.
Yep. See? Use the Venn diagram to identify the population and the sample. Okay. The population is going to be the one in gray, the big thing. The party of registered voters in a certain state, and the blue one will be the sample because it's a subset, it's a portion. The party of registered voters in the state who voted in the last election. Remember, sample is a subset of a population. Identify the population in the sample. A survey of 157 law firms in a country found that the average hourly billing rate of partners was $580. What's the population, guys, and what's the sample?
All law firms in the country.
All law firms, yeah, exactly. And the sample will be which one of the four?
In the country.
All law firms in the country, that's the population.
Oh,
The
sorry.
partners?
Not all the partners. No, that's not what we surveyed. The sample is what we used.
Law firms that were surveyed.
Exactly. He tricked you. He didn't put the number, but it's the law firms that were surveyed. Okay. Describe the sample data set. It's the average, not the 150 law firms. We're interested in the average hour. So the average hourly billing rate for partners of 157 law firms was 580. So if you guys want to be a lawyer, you know how much you'll be making an hour, $580. That's good money. Determine whether the underlying value is a parameter or a statistic. A parameter comes from a population, a statistic comes from a sample. A study of 776 adults in a public restrooms found that 23% did not wash their hands before exiting. Does the 23% refer to a population or a sample, guys?
Sample.
Sample. There are more than 6,000 adults, guys. How is a sample related to population? Or why it's shown again? A sample is a subset of a population. All right. Okay. Determine whether the variable is quantitative or qualitative. Your address.
Qualitative?
Yeah, because it describes, it's a label, guys, to identify your house. Just a label, qualitative. The number doesn't mean anything. Determine whether the variable is quantitative or qualitative. Wait times.
Quantitative?
Definitely, because wait times are in numerical measurements. They're not attribute. Attribute means description, label. Determine whether the variable is qualitative or quantitative. Heights. The heights are quantitative, guys, because they represent measurements. Anything that represents measurement is a quantitative. The list of books that your friend read for school for the past 5 months is shown below. Identify the level of measurements of the data set. Explain your reasoning. So this is a list of books that your friend read for school the past 5 months. It doesn't say which one he read first and which one you favored. So this is just a list, of qualitative data, guys. It's nominal. If he put 1, 2, 3, 4, 5, label them, it will become an ordinal, but he didn't. The graph to the right shows the responses to the question, how serious is global warming? Identify the level of measurement of the data listed on the horizontal and vertical axes. Okay, what do you think with the data listed on the horizontal axis? A, B, C, D, E. Very serious, somewhat serious, not too serious. Words, but they are ranked. What would that be, guys?
Ordinal?
Ordinal. These are words, guys. Qualitative, but they ranked them A, B, C, D, E, so it's ordinal. Now here, these are numbers, percent, so it must be a ratio here. The regions of a country with the 6th highest level of coal production last year are shown below. Determine whether the data is qualitative and identify the data set. Well, this is not a qualitative, guys. It's quantitative. It's qualitative. It's names of regions, so this is qualitative. He didn't mean here to say, well, probably he did. Number one, probably the highest, the second highest. If this is the case here, what would this become, guys? It's between nominal and ordinal.
Ordinal.
Yeah, ordinal. But I want to check, guys, if he meant that by numbering 1, 2, 3, 4. So I'm going to check the answer. Otherwise, it's going to be nominal. Yep. So it means 1, 2, 3. It's ranking. What's the difference between an observational study and an experiment? An experiment, guys, you bring two groups. One will get the treatment and one will get nothing, and then you compare results. An observational study, just observe and take notes. So which one it's going to be?
A.
Yeah. You don't make any changes for observational study, guys. You don't do an experiment. That is correct. Determine whether a study is observational study or experiment. To study the effects of social media on teenagers' brains. Researchers showed that a few dozen teenagers' photographs that had varying numbers of likes while scanning the reactions in their brains. What do you guys think?
Experiment.
The effects of social media on teenagers' brain. An experiment because it applies a treatment. Let's see. That's good. It is an experiment because they show them a few dozen teenagers' photographs. So then when they do an action, just to trigger, a different action, it is an experiment. Identify the sampling technique used. We have 4 sampling techniques, guys. We have a stratified, where we divide the population into segments and we take from each segment and put them in the sample. Cluster, we divide population into segments and we take the entire segment and put it in the sample. Systematic, we create a system like every 4th person, every 5th, that's a systematic. And convenience is when you survey only the member of the population that are present, just for your convenience. And then we have the simple random sample. An example of simple random sample, guys, you put numbers in the basket and you pick 5. That is a simple random sample. After a tsunami, a disaster area is divided into 250 equal grids. 50 of the grids are selected and every occupied households in the grid is interviewed. What kind of sampling technique is?
Cluster.
Cluster, exactly, because you took 50 of those grids and you interviewed every single one inside the grid. Since the divided area into grids and a random sample, no, that's not that, it's C. What potential source of bias are present, if any, guys, when you do a cluster? Let's see. Sample are easy to get. The grids may not be representative of the population. That's not, certain grids may have been much more severely damaged than others. Yeah. They may have been much more severely damaged than other. The grids that are selected may not be represented in terms of damage. I would go with C. We talked about this example before, guys. So that's the answer. Identify the sampling technique used and discuss the potential source of bias, if any. Every 12th person entering a library is asked to choose his or her favorite author from a list of 5 different authors that includes a description of each. Okay, every 12th, guys, you should be easy for you. This is a system. We're creating a system, so it must be a systematic. What do you think the source of bias would be here? Read it and let's see.
There's no potential source of bias.
You don't think there is a bias here?
Yes, because they're
Uh,
given a list. So they can only choose from that list.
I think it's B, people who don't enter the library are not sampled.
people who don't, okay.
So A.
The wording of the question may direct response toward a particular author, but it is possible that they don't know about the authors, you know, just even the 5 of them. We're asking every 12th one. We don't know, you know, just, I think that's fine, you know, just to ask every 12th person, unless if people who enter in the morning are different from people who enter in the afternoon. Oops, what happened? Just 1 second, bring it back. There you go, guys. There's more than one answer here. If there is a regular parent to the people entering a restaurant, the sample might not be. Why does it say restaurant here? The answer has changed. Oh, it's different. Yeah, I mean, that could make sense, and that's what I was thinking about. It could be, guys, that people who enter at different times have a different perspective, so that could be an issue. And as you said, the wording of the question might direct respondent toward a particular, you know, just book, because he's asking you in particular about 5 books, and there are tons of books at the library. The reason why this changed, because I don't know, just when I lost the page, I put it back, it gave you a different question, randomly generated, but it's the same thing. Here he says restaurant, we have a library. Oops, let me just remove this. Determine which number could not be used as a probability. Remember, a probability, guys, is between 0 and 1. So which ones, guys, do you think it's not between 0 and 1? There are 2 of them.
C.
C is bad,
And
that's
E.
negative. And the other one is E.
E.
Yep. This one, guys, is below 1. 33% definitely is 0.33. It's below 1. 0 is okay. You could have a probability of 0. And 0.002 is... remember, when a probability is less than 0.055%, it's called unusual. Anything that's less than 5% is unusual. A random number generator is used to select an integer from 1 to 500 inclusively. What's the probability of selecting the integer 912? What would be the answer, guys? Should take 5 seconds to answer.
0.
0. There is no such a number, 912. So your chance of getting number 912 for a basket that has number from 1 to 500 is 0, even if you play 500 times. The probability an event will happen is 13/17. What's the probability the event will not happen? The 2 probabilities must add up to 1, guys. So what do you add to 13 to make it a 17?
4/17.
Yep. Oops. Let me fix it. Just press the tab key and then we'll take in. I got the fraction from there. See, we're good. A restaurant offers $12 dinner special that has 4 choices for an appetizer, 11 choices for an entree, 3 choices for a dessert. How many different meals you can select? An appetizer, an entree, and a dessert. What do you do with those numbers, guys? You multiply them. So it's 4 times 11 times 3. Don't put this as an answer. It will not accept it. You need to type a whole number. So it's 44 times 3, which is 132. And that would be the answer. So remember, if you do 3 different things at the same time, and one thing can be done 10 ways, another one 15 ways, a third one 20, you want to figure out how can you do all those things together, you just multiply the outcomes. Just like rolling 2 dice, 6 times for the first one, 6 times 6 choices for the second one. How many choices for all? It's 6 times 6, 36. And that's an example like that. A realtor uses a lockbox to store a key to a house that is for sale. The access code for the box consists of 4 digits. The first digits cannot be 8, and the last digit must be odd. How many ways we can do that? Let me just do this on. That's a good question. So I'm gonna annotate. Okay, so we have 4. Okay, guys, how many choices do we have for the first digit? It says it can't be 8. So how many choices are left?
9.
9. You could have 0, 1, 2, 3, 4, 5, 6, 7, not 8, 9. So it's 9 choices. He didn't say anything about the second digit. So it's 10. 0 to 9. This is 10. And the last one, he says, must be odd. How many odd numbers are there from 0 to 9? So we have a 1, a 3, a 5, a 7, a 9, 5 of them. And you just multiply, guys. 10 times 10, 100, times 9, 900, times 5, 4,500. And put the answer right there. That's it. All right, and click next. Okay, let me just clear here. A probability experiment consists of rolling a fair 6-sided die. What's the probability of event below? Rolling a 4. Well, there's only 1 4, guys, on the die, so it's 1 out of 6. That's it. Type an integer or a decimal rounded to 3 decimal places. So we're going to divide 1 by 6. Just to show you how to enter the answer. And he wants 3 decimal places, so it's going to be 0.167. So I'm going to go back here and put 0.167, and that should give me the correct answer. A company is conducting a survey to determine how prepared people are for long-term power outage, natural disaster, terrorist attack. The frequency distribution on the right shows the results. Use the table to answer the following questions. What's the probability that the next person surveyed is very prepared? Okay, guys. There's the fraction. He wants 3 decimal places, but let me show you the math first. So you guys agree with me that the numerator should be 277? And what's the denominator? What do you do for the denominator, guys?
Add up all the frequencies.
Add them all up. This is the all possible outcomes. He didn't tell us how many total, no? So we'll just add them. So 277.
So it's 2,207.
Okay, 2,207. And just divide. Okay, I got 1.26 to 3 decimal places. 0.126. Move on. One more question, guys. Classify the following statement as an example of classical probability, empirical probability, or subjective. Classical, guys, is the number of favorable outcomes divided by the number of possible. Empirical is just like the previous example, when you have a table, frequency table, and ask you to find a probability. Subjective is based on a guess. The probability that a randomly selected number from 1 to 250 is divisible by 6 is 0.164. This is, guys, a classical because 250 is the denominator, and you can figure out how many numbers are divisible by 6 and put them in the numerator. So it's a classical. Okay, not intuition. Yeah, that's the one. It deals with continuous, statistical based now from every number from 1. Oh, every number from 1 to 50 has an equal chance of being selected. That's a classical definition. And last one, and then I'll do the rest, guys, of them. I'll just do a separate video for the remaining 15 questions. Use the frequency distribution, which shows the number of voters in million according to age, to find the probability that a voter chosen at random is not between 45 and 64. Not between 45 and 64. What would you do, guys?
Should you add up all the other ones?
You could and divide by the grand total, or look what you can do. You can do, let me just do the, you can do 58.5, which is the 45 to 64, 58.5 divided by the grand total. And whatever answer you get, guys, is subtracted from 1. You get the answer. Or just like you said, you can add 8.3 plus 10.2 plus 22.9 plus 26.9 plus 29.7 and divide by the grand total. Okay, guys, I'm gonna stop